Luca, on your go.
Bring it on.
Oh, no!
I'm Nick Uhas, and I'm here with Rihana Mungin, who is a research assistant currently studying slime.
We're thrilled Nickelodeon asked us to talk about two amazing things.
Me and you! Not today. The first one is slime. Yes, the green gooey stuff we love. And the second, space.
All right, this is gonna be out of this world.
Out of this world. Slime in space.
Now, why slime? Well, first, the biggest celebrities around the world have been slimed by Nickelodeon. It's a huge honor. Nickelodeon wanted to step it up even one more notch and send slime to space. That's right, they sent slime to the International Space Station.
How do you send slime into space? Shoot it really hard out of a big cannon?
I say you put it in the rocket as fuel. Imagine how cool that'd be when it takes off, it like squirts out slime.
I mean, I guess you would put it in a spaceship.
With an astronaut. I'm kidding, I don't really know. You get a slingshot, pull it back as far as you can go.
You could send slime into space using a slime rocket.
Kick it hard enough, you could probably get it up there.
Well, I think that you would send slime to space in a rocket ship, maybe?
And lift off.
There goes slime in outer space! Nickelodeon invited me to the rocket launch. Oh my gosh! And I will say this, I enjoyed it so much. I almost had this little mini, excitement overload. Oh! Rihana, how were you involved with the project?
When it was time for the experiments to happen, I was in the room helping the NASA teams direct the astronauts so that we could get the data that we needed.
Wow, so you're like kind of a big deal. I'll get your autograph later with slime.
Ready? Ready. Fire it in there.
So why did Nickelodeon want to send slime to space? Because the International Space Station flies at more than 250 miles above Earth.
Check. All right. Welcome on board. This is Team Slime. I'm Luca.
And I'm Christina.
And this is Drew. And today we are in an off-the-Earth environment, and so we want to see and study how slime behaves in orbit.
Tell me more about what the astronauts did with slime in space.
So the astronauts did a number of demonstrations with the slime so that we can see how it reacts in the microgravity environment.
Break in this little bend so we can get some slime out.
Microgravity makes things react differently in space compared to on Earth. Take, for instance, coffee or water. On Earth, you can pour them, but in space you can't because everything is weightless.
That basically doesn't look like water. I mean, you can tell that it's globbing around, but it just doesn't look like water.
To hear more, let's talk to Don Pettit, a NASA astronaut who's been to the International Space Station. Don, can you tell us why water reacts the way it does?
Okay. From the water's perspective, it's reacting exactly the same. When you go into orbit, you've effectively removed the gravitational force, and now surface tension force can dominate.
This is why Nickelodeon thought it would be fun to see what happens to a substance like slime when you sent it to space. The amount of scientific discovery that was done in space has led to a lot of data that we can use. This information will help in the development of new life support technology.
I think it's time to play with slime, and to help us out, we've invited friends to join us.
We have a group of kids who are helping us recreate 3 of the slime demonstrations to see how it's different on Earth. Who knows what slime is?
Slime is like a squishy thing that you can play with.
So Petunia, what exactly is slime? Well, slime is a crazy sticky, crazy green,
Viscous liquid sort of thing.
Goo. That's my best explanation of it.
It's...
It is very cold and slimy and goopy and...
wet.
Green stuff that squirts out at you anywhere you're at Nickelodeon, you never know.
The technical definition of slime is a mixture of ingredients that come together to create a polymer substance.
Oh, whoa! Wow! I want to dunk my face into there.
Is slime a solid or a liquid?
Yes.
I think slime is a combination of liquid and solid.
Well, I would think that slime is a liquid because it can run through your fingers.
I'd have to say it's probably in between.
I don't really think it's a solid or a liquid.
I would have to say slime is definitely a liquid.
Actually, it's part solid, it's part liquid.
It's a gas. It's a gas.
It's a gas?
I'll prove it.
Happy blob.
This was the first time ever that slime has been in space, so they had a lot to test.
What do I think happens to slime when it gets sent to space?
First couple days, slime will be more of an introvert.
I think it becomes more of a solid.
I think it would probably be like a liquid.
There's no gravity, so you could like throw back and forth.
It's just gonna kind of move around and jiggle.
I would envision slime just being all over the spaceship, like just everywhere.
It produces more slime and then more slime.
Spaceballs.
So we're gonna see some of the demonstrations that the astronauts did with the slime and kind of see how it's different than other objects. Are you excited?
Yeah.
Okay, good. I'm glad you're excited.
This is
We're
exciting.
running this experiment in our space station, essentially kitchen, or what we call the galley where we normally eat. Oh, blob flying away, trying to fly away.
So she is squeezing slime
That's a slime bubble.
out of the bag.
Wait, that's a slime ball.
Yeah. So remember when I was squeezing it out in your hands? It just plopped in your hands? Gravity is what's pulling it down into your hands, and there's no gravity, so it's just going wherever.
We're breaking free! Boom!
Wow.
Houston, we have a slime bob. It is a perfect sphere.
Now the crazy stuff is it looks, instead of looking like a bubble, it looks like a balloon.
Shiny though, that's the crazy thing. I
Yeah,
usually
it's
think
so
of viscous things as not being shiny.
It's compared to
Makes it
a
seem
bubble
like
of water.
Water
Wobbles.
has a lot more wobbly oscillations or standing waves.
Now look at the difference between the water compared to the slime. Do you see how it's moving more?
Look, it's like a bubble.
So they call these droplets because bubbles have air in them, like a soap bubble, but this is all slime.
Okay, we're gonna try and rotate the blob.
Oh my goodness.
Whoa.
So see how she's rotating it?
That's
what's
the transform.
Yeah.
It looks just like a
So
cell
now the
dividing.
question is it gonna eventually recombine into a sphere? It seems like it's just staying the same. I
Wow.
wonder if that's the viscosity. Oh, and look, just that action made it.
Go back.
Yep. Uh-oh. Oh.
It was easier to drink it.
That's cool. I want to drink. I want to eat it.
Only water. They don't eat the slime.
We've got waveforms.
This is the demonstration that we're gonna do here.
It looks like it's alive by itself. It looks like one of
Yeah.
those weird Jello things that are in cartoons.
So we saw the astronauts move water and move the slime around with special paddles. Look at how different the face of the paddle is, and it's coated with a hydrophobic coating. What do you think that means?
Slime does that mean fear of water?
Yeah, so it's almost waterproof. We are gonna start with water.
I bet you it's gonna bounce off. What? It turns into droplets.
Look at all the small ones.
Whoa!
Fill the syringe. Fill the syringe.
Don't go too far. Just make sure you don't touch.
Very precise, very precise. Now try moving the paddle.
What? What?
The slime has a different viscosity. Has anybody heard of the word viscosity?
I think so.
You don't know? It's a measure of the liquid's, almost like its thickness.
Whoa.
Okay, so remember what the astronauts were doing? They had a lot of slime on the paddle, and then they were moving it up and down.
Try that.
Faster.
It's just going just down.
It's hydrophobic.
In space, slime appears to wet or stick to the hydrophobic paddles. But on Earth, it quickly pours off.
So slime is a super viscous, non-Newtonian liquid.
What is a non-Newtonian fluid? Well, I need to go back to 5th grade.
A lizardtonian fluid?
Isn't that the secret ingredient to a Krabby Patty?
A what?
I'm not even gonna pretend like I know what that means.
Fluid that does not believe in Newton.
Maybe I think non-Newtonian is someone who can handle slime.
A non-Newtonian fluid is basically a fluid that doesn't follow the Newton law of viscosity.
It means that it behaves like water, except that its density is about, what, 10,000, 20,000 higher. 20,000
Way thicker.
higher.
Thick honey. Look, it doesn't want to connect. You're touching. There it goes. Whoa, and now it's growing.
Slowly moving away. The bridge doesn't move, and then at about this distance, it just does it by itself.
What would happen if they pulled it faster?
They put it like fast. It'll get way longer, but you can barely. Yeah, but it would be like
It'll be just a really thin line?
Yeah.
Okay.
See what I mean? See what I mean?
Little satellite drops appeared all at the same, what looked like the same distance from each other.
When they're pulling it apart on its own, its surface tension and the wetting properties of the paddle is what causes it to drain that way.
So cool.
What do you think the astronauts are setting up for right now?
Like target practice.
Target practice? Who do you think the target is?
Him.
Luca, on your go.
What could possibly go wrong?
3, 2, 1, pass up!
Yo!
Wow, good thing we have goggles. That is so awesome. It reformed with the velocity. Oh no! I can't see them! I can't see them! Oh, you've been slimed.
Okay, I'm being phagocytated by slime.
So do you think there's going to be anything different?
No.
When you hit the target?
Yes. It'll splatter. And like, if you don't make it perfectly, it's just gonna arc up and splash the ground.
3, 2, 1. If you push hard enough, there's almost no difference between squirting the slime on the space station versus Earth. However, on Earth, gravity has an obvious pull and causes the slime stream to travel in an arc, falling faster towards the ground, eventually making a mess.
I'm gonna try and use my fighter pilot skills.
In space, the slime is basically weightless. If you shoot it far enough, the slime will eventually hit the wall. Well, unless an astronaut catches it.
3, 2, 1, go!
That's slime in space.
That's some slime in space.
I got it in my mouth.
How's it taste?
It's like nothingness.
We just watched Christina pop 2 different balloons filled with slime in space.
Let's see what happens. Does the balloon just shrink around it? Whoa! How's that for a slime balloon?
Alright, I'll hold it and you pop it.
All right. Oh no!
Oh wow.
That is so awesome!
It completely engulfed the balloon.
That is
Is
awesome.
it inside?
Part of it is.
Or is it 2 different parts?
Let's pull it apart. It's 2 different parts.
Check these out.
I thought for sure it was going to explode in that balloon, but it's so viscous and sticky, it had enough tension to stay together.
So I'm gonna pop this balloon over the top of your head.
Yeah.
Do we have a hypothesis as what's going to happen?
I'm gonna get messy and my mom's gonna get mad. I think it's gonna explode all over her head. Yeah,
Okay.
Have I ever been slimed? I've been slimed, and it's really slimy.
I've definitely been slimed. It's gooey and goopy.
Almost if like you were to jump in a swamp, and I've never jumped in a swamp.
It was cold. If you want to annoy your friends, dump it all over.
It was basically a slime shower because I lost a game on Nickelodeon. And they were interviewing me and I couldn't hear anything because my ears were covered in slime.
I feel like it would be an honor to be slimed.
Oh, you ready?
Yeah.
Okay, 3, 2, 1. If the balloon is punctured in the right place, the balloon rips apart and peels away from the slime, leaving it like a round blob. Almost like in the shape it was when it was inside the balloon. This happens on Earth too, but the slime would fall and hit the ground.
Wait, no, let's see.
Whoa!
Slime in space! I can't see.
You know, I think at the beginning of this session, we had some questions and we found some answers. But the best part was now we have more questions about why it behaves in a certain way and not in the expected way.
Just like all the other science we do, you cannot replicate these experiments on the Earth. You need zero gravity to see some of this behavior.
The International Space Station is the only place where you can do this. So don't try this at home, or if you try, expect something very, very different.
Exactly.
Those demonstrations were insane.
We learned a lot. I also learned that doesn't matter who you are, everybody loves slime.
From the team at Nickelodeon, goodbye and stay curious.
That is all from the International Space Station. Signing off. Oh, and some slime flying away.